Everybody, I'm Sean. I'm from Facebook. So today I'm going to talk about the evolution of Dataswarm. So basically, Dataswarm is a Facebook scale data platform, data process platform. So basically, this is a little bit off the topic, but we just want to share what we learned and what we are evolving to from this project. Oh, this micro. Yeah. So first, what is Dataswarm? So basically, Dataswarm is a large-scale managed pipeline execution platform in Facebook. So basically, it's the major big data analytics platform used for batching processing in Facebook. So as of today, it's scheduling and executing millions of tasks daily. So the task here is pretty much just execute workload. The workload could be a SQL query, could be like a serverless function. So it also support like a heterogeneous workload. Like I said, it can run SQL. So basically, you can choose whatever you computer engine you want to use, like Spark, Presto, and MySQL. So Facebook has all this in managed service. So people in Facebook can easily choose which computer engine will serve the best for them. And also you can just execute the batch command. So you can download your own batch command, batch tool and run it as part of the task. And finally, we support like serverless functions. So you can think about it support like Python, support Hack, PHP, and it can support any language you want because the system itself is extensible. You can provide your own like operator and support new language in terms of the serverless functions, and also many more. So I cannot list all of them here because we have hundreds of operators and you can use, and also they do different things. Like you can also send the email via the operator. Then basically the core functionality of Dataswarm is a Chrome-based recurring scheduling system. So basically we the pipeline user defined is executed as a given frequency at a given time. So you can say, I want to run my pipeline every day at 8 a.m. I want to run my pipeline every month. I want to run my pipeline every Wednesday. All the semantic cron support will be supported by the system. So beyond all this nice functionality, we provide the management tool set. So this is very important for a managed service or platform because users do want to do a lot of like operational, like monitoring, like troubleshooting, and also they want to do some maintenance work against their pipeline. So we provide a full set of tools and UI for that purpose. So let's see the Dataswarm in a nutshell. So basically, first step, user will start authoring their pipeline. So we provide the Python-based pipeline API, so they can start writing the pipeline definition by using Python language. And then we provide the linting for the pipeline itself in Nuclide. I'm not sure if you guys know about Nuclide. Nuclide is a Facebook extension for the Atom. So basically, provide a very nice extended functionality for the Atom. You can do like debugging, you can do like type checking, and automatically happens in the IDE. So next stage, once you start finish the authoring, you want to test and validate. So we'll provide the tester, so you can run the pipeline in a test environment and validate the result. And then we also provide the linting tester so that we can catch the error, like static error, semantic error, static error or syntax error in your tester. Because some people, they don't want to use Nuclide, they just want to use Emacs or VIM. So this is a second chance we catch the static errors. So we also do the diff addition. Diff here means like when you submit a diff for review or you submit a package for review kind of things. Then we also do the validation in the diff review UI. So the reviewer can see the static validation failure as well, so that they can reject or accept or give you a recommendation for fix. So next step, after you finish all this testing validation, you want to deploy. So we provide packaging, automatic packaging, and provide the continuous integration. So you user don't need to do anything. So basically they just land or they just commit the diff, and there will be a system running in the background. and package your pipeline and deploy it automatically. So everything happens automatically. So next step would be a schedule. Schedule, as I mentioned, we support like Chrome-based DAG scheduler scheduling, and also we expose the pipeline execution progress on dashboard. And finally, beyond the dashboard monitoring, because which is more like not that proactive, so we'll also provide alerting so that you don't need looking for the errors on the dashboard frequently. You can just wait until the alerting come if there is anything you need your attention. So finally, like operational aspect. So we support backfill. Backfill is a term like represent the action. You want to regenerate your data. So basically, because this is a scheduling platform, we run the pipeline or run the data processing day by day or hourly by hourly. And when you change the logic, you may want to regenerate the data has already been generated for past a week or past 3 days. So that kind of action is called backfill in Facebook. So we provide backfill tooling so that you can easily like regenerate your data or historical data. And then finally, troubleshooting is very important because if you have a failure on your pipeline, you do want to know where and why it fails. So basically, the first part and the third part will be user interactions, and between all of them, everything is system automatically handled, so there is no user involvement. So next, how the pipeline looks like. I gave you a very simple example here. So you can see this is Python based, and the pipeline itself is self-compiled API. So you can see that here you define some sort of global metadata for your pipeline. You can say, oh, I'm the owner of this pipeline, who is on call, which team is on call, and what is schedule. Schedule is pretty much a constraint. At daily here is a shortcut for the runs at midnight every day kind of constraint. This is shortcut. And then when this pipeline gets compiled, actually we just simply run the import function of Python. So what it does is we just execute the module scope, the global scope of this pipeline. And at the end of the compiler in Dataswarm, we are going to look for the global variables that has a type of the operator. And the name of the global variable would be the key. That would be the task name of the task or this kind of operator instance. And then you can also see there is a dips list in each of the operator definition, which represent the dependency between tasks. Right. So basically, what this says is the goodnight moon will run after hello world finished successfully. So this creates a dependency. So basically, in Dataswarm, as I mentioned, we provide a set of operators user can choose from. So in this example is a batch operator, which you can provide a batch command and run it. And we have others, like we have Presto and Spark, and also MySQL. And we have co-operators provided by platform as a default, which is well written and well supported. And also a user can also define their own operators and create extension on top of the platform and share that with other users and used by them as well. So basically, this platform itself is extensible. So as I mentioned, we also support like dependency between tasks by using the deep list. So all the upstream must be satisfied before it can be executed. So here is today's or kind of past architecture. So you can see from the beginning that we provide a set of dev tools, linter, tester, backfill tool, and maintainer. And we provide the static validation. We provide the continuous integration, which is a DAG builder running continuously, looking for the new diffs or new commits. And compile here means the step I mentioned before as importing the module and looking for the global operator instance. And then write the task metadata into the MySQL DB, which is a source of truth storage in the system. This is today's architecture. And then we have a scheduler run as a hosted services, which is sharded. And it tries to tell the task metadata from the MySQL DB, and then start dispatching the task into a container service, actually start the worker and execute the operator itself. So operator itself can just run a bash, can just run a serverless function. And then the work itself will also update the task instance back to the DB. So this is a loop that the system relies on. Is MySQL here is a very critical components in the whole picture, because it hosts, first, it hosts the pipeline or task metadata. Second, it actually hosts all the runtime states, and all the runtime states will be used by scheduler to do the DAG management or dependency management. By the way, actually that architecture is not good. I will mention why. And we are involving into new architecture, and we are working on it. And also part of it has already been done. So I want to share what we did for the past and involving this platform. So first, Dataswarm started as a as a single executable, contains everything. So you can think about it, it's a Python executable, contain all the tools, contains the runtime, contains the operator implementation, everything within it. We deploy that single package when we do the release, so that it's pretty much a single box solution at the beginning. So basically, it resolved some few users' problem at the beginning, and it did that really well. And then going along, once the system started, then more and more operators get added, because more and more users want to use this platform and want to do their own business logic. So they're adding more and more operators. Then the team actually started enriching the toolset, because the user will have a feature request, like they want to do backfill, they want to do testing, they want to do maintenance. Then they started like requiring more tools. Then we build those toolset, and we started like improving the monitor UI as well. Because once you have all these nice tools, CLI tools, you want to use you want to have a nice UI as well. And then we started improving the monitor UI. And later on, we start improving the performance. At the beginning, the scheduler is based on another scheduler system within Facebook, but that design is not efficient. So we started like think about, should we have our own dedicated scheduler designed just for the system and make it perform really well? Then we started doing that. Then we implemented the dedicated scheduler I mentioned before. So later on, we started to improve the usability. Like we introduced a static validation. At the beginning, there's no static validation. Pretty much it relies on the Python chat. But as you can see, you can also write a SQL function, a SQL query in the pipeline. So we provide the static validation for the SQL query, and that we catch the SQL syntax error before you deploy it into the system. And then we do a little bit better backfill improvement, and just trying to add some incremental features into backfill toolset. This is what we're doing for past few years. And what we're doing now, and pretty much we have done all this for the past year, past half, is first thing is we improve the extensibility. Like I mentioned at the beginning, the system is created as a single executable, and the user start adding the operators, their own custom operators into the system. And also we have a lot of downstream, upstream dependencies, like the Spark Presto client library. They also built into this single object or executable. That causes a lot of problem for the for the operability. Like when we release, if any user provide functionality or the upstream dependency break, the entire release break. So everybody just impact everybody here within one single package. So we did like a kind of re-architect work, trying to break down the one single executable into multiple modules, so they can be, so the multiple modules can be released separately with their own release process and cadence. And the second one is we improve the operability. So like I said, we with the extension or extensible work, we can separate, actually we already separated system and user code. So basically user provided operators would be in their own extension, and the system operators, like the platform provided operators, will be part of the core. And then we start defining the platform SA. And before that, we don't have a good definition of SA. Now we have that. And then we enhance the incident and the disaster recovery process. So that means if there is a SAP or incident that happens in the infra, we have a good tool to automate the recovery process. So finally, we are improving the scalability. We are sharding the backbone DB, like we mentioned before. Actually, it's a single instance of DB. Now we are sharding it to improving the scalability. Okay, so next, what we're going to do in the future. So we want to further improvement over the scalability and the availability. So the one of the requirements and the path we are doing is all the critical component or services or databases will be horizontal scale. So that means we can just add more instance and it can support a bigger scale without re-architecting the system. So then we want to further improve the operability. So we are moving into microservices environment instead of modules. Today is kind of, we have different extension modules, but we are trying to move into microservices. And the second thing is like the entire platform will be fully operated by a clear service API contract and the SAs. So that means when user interact with the system, we give them a clear definition of API contract, and we are telling them what exactly the QPS is we can support and what exactly the SA would be, and the team will support that. So and also we're aiding the multi-tenancy for the protection because we have thousands of users are using this platform, and some users, they have higher SA requirements. Their workload is more important than others. So we are trying to create the multi-tenancy so that we can provide security, resource isolation, and privacy protection for different tiers of users. That's what we're doing right now. And then we are going to like improve the usability further. So as I mentioned, as of today, Dataswarm only support Python-based API, and we are trying to create a language agnostic pipeline definition language so that you can define your pipeline using any language you want. And then with that, you can build your own platform, framework, and language on top of that. You are not bounded to using that Python API. Finally, we are doing more improvement over the backfill experience. We're trying to automate all the manual steps we can identify and trying to automate it as much as possible to reduce the time spent in the system for doing backfill. So basically, I want to share the path we're taking. So this path is very typical. It's a maturity of the business critical platform. So basically, we started with a very simple architecture so that we can validate the idea and we can gain adoption because it's simple. And also, we were adding more and more features like operators and toolset to gain the adoption. And we improved the scalability step by step. At the beginning, maybe 10 users or 100 users using it. Later on, like 1,000 users, then thousands of users. Then the scalability requirements was increased a little bit by little bit. So we improved the scalability step by step. And then we are switching the focus on operability and availability because the system becomes more critical compared to when it started. And now this is major platform used in Facebook for the big data analytics. So that's why we're trying to switch in the focus on the ability and availability, and while also we are improving the usability, as I mentioned before. So basically, another one we're doing is instead of improving the scalability step by step, we are re-architecting to satisfy next several years growth. So basically, we're not doing like step by step, but we're projecting the growth for next few years and re-architect. So this is the path we are taking. So basically, this is a new view of the system. It will be an API layer plus microservices. So API layer, we support different scenarios, like registration of the pipeline, the management of the pipeline, monitoring, and also providing insight of the pipeline. And then we have microservices. They serve different purpose. And we have scheduler doing the scheduling, process service doing the exposing the data, pipeline metadata, and the pipeline status. Then we have databases. They are sharded and hosted on different tiers of the MySQL. And then we have backfill related services. They work with each other to serve the backfill purpose and the automation as well. And we have troubleshooting service, and we have other like pipeline analytics service trying to provide the insight. We have the metadata publisher trying to provide the insight while the real-time publishing. So all this is a new architecture we are heading to. So this is the overall system, how it looks like going forward. So you can see we have an API layer trying to, so the user will actually call the API instead of writing their Python pipeline. And the API will actually have two paths. One path is a recurring pipeline path that will serve the recurring pipeline use case I mentioned, like a daily or hourly or weekly pipeline scheduling. And then we have ad hoc pipeline use case where user just run a one-off pipeline and get the result. Then they have a different environment. So basically the recurring pipelines will go through the multi-tenancy architecture. So each tenant will have its own database for the DAC metadata, and it has own set of sharded schedule deployment, and has its own shard, DB shard in the tenant pool. And then all these details will be hidden by the proxy service. So proxy service will actually talk to all these sharded DB and trying to find where the data is and redirect the request. And at the end, outside the world, like the workers I mentioned before, and also the monitoring UI, they will only talk to the proxy service. They are not going to talk to the DB directly. So all the details, business critical details are hidden by the proxy service. And the proxy service is serving the on-demand request. So how about the real time? So we are building the pipeline metadata and the state publisher, trying to take in the changes in all this DB, and then publish it into a queue, a global queue, a public queue, message queue, so that external users, they can build their own solution for indexing. Like Elasticsearch can ingest real-time updates and then index it and for search purpose. And also the execution, ad hoc execution engine will be used by the ad hoc pipeline and also by the backfill as well. So the backfill, you can do the backfill control plan and also the monitoring or data plan. So you can launch your backfill, you can monitor backfill, you can pause and resume backfill. So basically this is overall architecture we're heading to. So yeah, that's it. Do you have any question? Let me. So which slide? This one? Okay. Okay, so the question is, this component, pipeline metadata and state publisher is part of the monitoring UI API set or part of others. So basically, yes, this is part of monitoring and also part of insights. So basically, monitoring, we expose the task status and also metadata in the future, because we are building the pipeline analytics service, which will listen to the pipeline change and pass the pipeline and pass the query, get extra metadata, like the AST of the query, SQL query, and also get the input and output of this pipeline and publish it as well. So in the future, we expect this publisher will also serve the real-time use case for the insights as well. Yes. So basically, we're sharding by the task name. So basically by the name, and it can be like a horizontal scalable, because like task is a minimal unit we're managing in the system. So basically one task, one row will be assigned to one tenant, and we can just keep adding more and more. And actually in the current architecture, we have a design of resharding, but because we allocate enough space for next 5 years growth, so in next 5 years, we don't need to do the resharding, but we have the design of resharding as well. Okay, so the question is, since we have the Python operator, how we manage the user provided dependency? Python operator. Yes. Okay. So this is very tricky in the system today. So basically, like I mentioned, we have a single package. Actually, that single package contains all of dependencies already. So if user want to use dependency out of that single package, they have to go through another path. They have to use a package, create their own executable. And in the operator, they have to use a bash operator. They have to use a Python operator to implement ABI kind of or serialization or deserialization between that executable and the operator itself. So what we ask him to do is either you start that executable and provide a serialized metadata one pass into that executable via the command line or a file, and then get the result back while like type or a file, and then deserialize it. Or you can just use a Python operator to create to call a service, right? So you can create your own Swift service, and in the Python operator, you just call that, and the Swift can handle the serialization and deserialization of the contract. That's what the approach we are taking, because managing the Python module kind of dependency is very hard, and yeah. Okay, so the question is how we handle the artifacts flowing from operator to operators. Okay, yes. So the system itself doesn't handle that. So what we do is we simply execute the task and we honor the task dependency. So user need to find their own way to materialize the result. So the major way they are doing is materialize the result into Hive tables. And then in the downstream operator, they just load the data from the Hive table and do some processing. And in many cases, other cases, they materialize the result into files, into a global shared file storage. And then in another operator, they can just read the file result from that shared storage and do further processing. Yeah. And also all this information is implicit. That means the system doesn't track it today, but we're building solution trying to understand the implicit dependency between operator and two operators. But as of today, they have to write down the table name or file name into the arguments of those operators. Any other questions? Thank you.